Let's delve into how the data center fabric infrastructure needs to change to support the fact that cloud native implementations and the new 5G use cases are driving a lot more volume and driving a more rapid pace of change from the applications themselves. Bruce, this must mean that the network needs to be more responsive to support this. Do you agree? And if so, how do CSPs solve this problem?
Yeah, for sure. I think we've gone from an approach where, if I draw comparisons to how we used to operate to kind of the current mode of operation and where that needs to evolve, we used to stitch networks, the fabric even between locations ahead of time before the workloads came along. We would, treat them as like infrastructure services. They would be provisioned well before the actual compute stack got built. And this worked. It worked fairly well, other than there's no degree of flexibility at that point, right? If you want to add services, there's a human that has to come in and add those services to the and services here I'm speaking of, subnets and routers and things like that. So I think, we've gone from that approach to where there's such a high cadence of change from these workloads, either scaling out horizontally and needing to be connected back to the same broadcast domains as, their corresponding functions, or even between clouds where you have, the whole aspect of edge cloud and having functions that are deployed there for latency reasons, and then having them need to talk back to a central location. So you can imagine in this world where you have hundreds, thousands of locations and thousands, hundreds of thousands of network functions, microservices that are deployed across your network, there's absolutely no way that this can't be automated. It's simply unsustainable to not automate this problem away. So I think, again, going back to my intro, this is where Kubernetes, I think, starts to play a very big role. And again, we saw this with some of DevOps. I mean, I'm going to steal the concepts and apply them to networking here, in that, there's been a bit of a breakdown of that typically very high wall between the compute team and the networking team. And PJ, you actually mentioned this in your article around, typically there was a clean separation of duties, and the networking team and the compute team ideally didn't talk to each other or tried to avoid talking to each other as much as they could. And I think those walls are coming down out of necessity, because they simply have to. But also we're starting to see a lot of the networking aspects get automated through the same interfaces that the compute world or the application world has been using to actually spin up their functions. So the obvious things here are, Kubernetes and things like Multis and network attachment definitions to allow you to automatically stitch services on the fabric based on some metadata that is applied to these pods as they spin up inside Kubernetes. I think that trend is only going to continue, where you start to see network and how it is consumed become part of the application chain, and that you will define a pod, you will define the networks that pod is going to be attached to. You'll do this all inside a single API, being Kubernetes. You'll apply that, and essentially whatever the network manager is, in our case, it would be the fabric services system, would automatically detect that pod had spun up and would automatically deploy the fabric. So yeah, I think those walls coming down and are starting to actually bridge the gap on the automation front, where the same interface is being used to automate the network versus the interface that's being used to spin up pods and services inside Kubernetes. These are the key things I see in this space. I don't know, PJ, if you had more.
Yeah. I mean, if you sort of take the concept of aligning the synapses, if you will, or the logic flow between what's required for an application and what the network needs to do to support it. If you expand that notion a little bit and just on the one hand, if we acknowledge that application deployments are being done in a CI/CD model. I mean, there's just no question about that. Then therefore, when a new portion of an application comes online that might need a different set of capabilities, in a subset of the fabric locations, for example, or there needs to be some adjustment soon, because customers want to use the capability, then the value of the adaptation, is just, emphasized even more. So there's that aspect of, just underpinning the value of the services themselves. And the other part that I think is quite relevant for CSPs and for some of their ecosystem partners is that applications have different topologies that they need to employ to get their functionality implemented. And it could be for partitioning on a locality basis, or a latency basis. It could be for resiliency purposes. But the point being that the forwarding domain, or the fabric infrastructure that's accommodating that diversity, that sort of multi-tenancy of users, when it's implemented to be dynamically adapting, listening and understanding what the variety, you kind of get this embedded governance function within the network itself that says, yes, I understand what you need, and in fact I can do that, so I'm going to go ahead and allocate that configuration. So yeah, so I think that aspect of diversity at scale is an inherent part of this, as you're saying.
Yeah. And I think 5G is a massive catalyst for this, and that they drive typically complex topologies. I mean, most applications on kind of the compute side of the world are simply, within a single data center, maybe with some, public cloud outreach, but typically within a single data center on a single subnet in a lot of cases. And so there's no real need for a complex topology or policy to drive, what can talk to what outside of what is already getting done in the compute stack for us. But yeah, you can imagine you have an edge location somewhere that's hundreds of kilometers away, and you're connecting it back to its controller essentially, which is another application that's running in a central data center, and it's there for scalability reasons. That introduces a fairly complex network topology and a whole bunch of points that need to be intersected and merged together, which is a big part of why we launched Adaptive Cloud Networking, is to try and solve that unique problem for some of these distributed functions. So yeah, it's definitely a 5G and networking functions have very, very complex topology requirements, unfortunately, but it does create again, an inflection point for us to look at our automation stacks and see how they can apply to this new world.